So, good afternoon, one and all. In the previous video, we have seen about the three possible ways of deadlock to deal with the deadlock system. Now, we are going to see about the first method called as deadlock prevention. Deadlock has been occurred. How we are going to prevent it? That's what we are going to see in this video. So, for a deadlock to occur, there are four necessary conditions should be followed. So by we need to have we need to ensure that at least one of these conditions cannot hold. We can prevent the occurrence of a deadlock. All these conditions should be satisfied. So what is the first one? We have seen it already, like mutual exclusion, hold and wait, and no preemption, and the last thing is the circular wait. So this has to be satisfied. What is mutual exclusion? There can be only one process inside the CPU. So that's what not required for shareable resources. Example, read only files can be there, or write files can be there. Must hold for non-shareable resources. What is hold and wait? Must guarantee that whenever a process requests a resource, it does not hold any other resources. So this way we can prevent from deadlock. If you utilize the resources more, deadlock possibility is more. If you utilize the resources less, what to say, like there won't be any starvation. No process will wait for the resource. So the next is no preemption. No preemption is if a process is holding some resources, request another resource that cannot be immediately allocated to it, then all resources currently being held or released. Okay, then next, circular wait. So what is circular wait? In a circular manner, each and every process should utilize the CPU. So this is the one of the example of deadlock. How with the help of threads and mutex lock, how we can use this prevention method. And we have one more thing called as lock ordering. Here going to see about the two transactions are happening. One is transaction 1 and 2. Transaction 1 is going to transfer 25 from account A to account B. At the same way, transaction 2 transfers $50 from account B to account A. How this deadlock is happening, we are going to see here. Okay. The next is deadlock avoidance, which is the second method. Deadlock avoidance is, which is the simplest and most useful model, requires each process declare the maximum number of resources of each type that may be need. Here we are going to see a problem which is called as Banker's algorithm. What this algorithm actually saying is the resource allocation state to ensure that there can never be a circular wait condition. What is actually resource allocation status? It is defined by the number of available and allocated resources and the maximum demands of the processes. And here we are going to see about the safe state. What is safe state is, if the system is in safe state, there exists a sequence of all the processes in the system such that for each P, the resource that P can still request can be satisfied, which means n number of processes can be in the sequence. If it is entering the safe state, which means the process has its own resources. Okay. What are the basic facts we are going to see about this Banker's algorithm? If a system is in safe state, there won't be any possibility of deadlock occurring. If a system is in unsafe, possibility of deadlock. And avoidance means what? Ensure that a system will never enter an unsafe state. Okay, a system is in a safe state only if there exists a safe sequence. So this is a better example for safe, unsafe, and deadlock state. Unsafe is in blue color, and inside we have deadlock, and the major portion is called as the safe state. So we will be seeing the example in the next coming video. Thank you.